going. We're going to work on finding some special products. So do you see that there, x plus 3 squared? Now on the homework, somebody had a question, which is the warm-up. How do you deal with this? You know what this isn't? It is not x squared plus 9. And I'm going to put an international interdiction symbol there. You know what that is? Don't do it. Why is this not x squared plus 9? Don't you want to make that x squared plus 9? Nobody does? Don't do it. Because x plus 3 times x plus 3. Isn't that x plus 3 squared?
Yeah.
Now we're going to use FOIL. Firsts, outsides, insides, lasts. Combine your OI. X squared plus 6x plus 9. See how it's not x squared plus 9? There's an OI. There's an outsides and an inside. Let's try it with x minus 2. That quantity squared. What's that going to be? Let's expand it out, right? And you use FOIL. X times x is x squared. Now when you get good at FOIL, you know what you're going to notice is that I can kind of do this in one step. When you get good, you don't have to if you're not ready. But x times negative 2 is negative 2x. Negative 2 times x is another negative 2x. Negative 2x minus 2x is minus 4x. Negative 2 times negative 2 is plus 4. If you're not ready to do that in your head yet, don't worry about it. Write down negative 2x minus 2x and then combine it. But eventually you want to get good at that and start like seeing it ahead of time. So far so good?
Yeah.
Let's try this one. 3x minus 4. Ooh, let's definitely write that one out. 3x minus 4, 3x minus 4. 3x times 3x. 3 times 3.
9 minus 4.
X times x. X squared.
Yeah.
So I've got 3x times negative 4. That's negative 12x. But here's another 3x times negative 4. It's another negative 12x. So what have I got here? Negative 24x. Negative 4 times negative 4 plus 16. So expand these out. Again, out of autopilot now. Don't do this. Don't just automatically square the first, square the second, do that. Because that's not how it works. All right, what's this one? Can we find a pattern? So I'm looking to see if there's a pattern here that can maybe save me time. No?
There is a pattern.
There is a pattern. I'll give you that hint. What is it, Sam?
A squared.
Okay, you're going to square this guy.
Yeah.
Yeah?
And then it's going to be a number and an exponent.
Okay.
And then an exponent.
Well, let's see. I like that you squared this. We do actually square the negative 4, don't we?
Yeah.
Now, what happens in the middle? You say 3x times negative 4. That's negative 12x. You do that twice. So it's 2 times this times this. So 3x times negative 4 is negative 12x times 2. So let's see. So you square the first one. That's this. You square the minus 2. That's that. Multiply these two times 2. So negative 2 times x, negative 2x times 2, negative 4x. Let's try it again, right? So square the first one, square the last one, and then multiply times 2. 3x times 2 plus 6x. Now, if you can remember that pattern, fantastic. Then you don't have to do this big expansion. I'll let you in on this. It's probably a little hard to remember that pattern for right now. Always expand them and FOIL them out. You'll see it again, and so I just kind of want you to know there is a pattern there. But if this one, less important if you can't remember the pattern. You just multiply them out, use FOIL. Don't forget the OI. Don't forget the OI. Now this pattern, the outside and inside, right? So this one, though, is a little more interesting, I think. I like this product. It's called the plus or minus pattern, right? The other one's you're squaring a binomial. It's a binomial square. This one is a plus-minus pattern. X plus 2, x minus 2. They're the same except one's a plus, one's a minus. So let's use FOIL. X times x. Let's see. X times negative 2. That's negative 2x, right? Do the insides. That's plus 2x. Positive 2 times negative 2. All right, we combine this, right? What's negative 2x plus 2x? Come on, right? Let's try this guy here. Let's do second row here. So I'm going to FOIL. What's x times x? X times negative 6. 6 times x. And then 6 times negative 6. 6 times 6. Yeah, just Matt is the only one in the room. So he's the only one who can do this.
Oh,
I don't know where everybody else went.
Oh, where'd you go, Matt?
So let's see here. These cancel out. X squared minus 36. Let's try this one. 2x times 2x.
4x squared.
4x squared. 2x times negative 1.
Minus 2x.
1 times 2x.
2x.
1 times negative 1.
-1.
Look. Go on again. What's this pattern? Oh, what's happening here, Ryan?
Square the x's for the exponent, and then you multiply the two constants.
Yeah, what's nice about this is, look, the oi cancels out. This one you're going to do what you feel like doing, which is square these, square that. A squared minus b squared. Isn't it? It's x squared minus 4. X squared minus 36. 4x squared minus 1. When you have this pattern and this pattern only, they are the same, the two binomials, except one's a plus and one's a minus. The oi cancels out. That's a really handy pattern. I want you to know that pattern. So if I want to find this pattern here, well, you square the first, you square the last, a times b times 2. That was the pattern we saw. If you don't notice the pattern, just expand them out if you're having trouble remembering. Right? A squared. AB plus AB gets 2 ABs plus b squared. Yes, ma'am.
So for that formula, would you do 2 times A and 2 times B and then multiply them?
No. Do A times B times 2.
Oh, okay.
All right. What's this one? Now, same kind of thing. You're going to square the first, square the second. Minus times minus is still a plus, right? A times negative b is negative AB times 2. Negative 2AB. And again, I am less concerned, with you remembering this pattern. Expand it out. That's a squared. Minus AB minus AB. There's your minus 2AB. Minus b times minus b. These two, if you can't remember the pattern, just multiply them out. You'll get there again. This one, I want you to know the pattern. It's the same except for plus minus. What's this one? A squared minus b squared. Now you can use FOIL. You get a negative AB plus an AB. They will cancel out. Alrighty. So we found the pattern. I'm pretty sure we did. The square of a binomial pattern is square the first, square the second, multiply these two numbers times 2. This is nice to have. You can remember that, great. If not, just FOIL it out. So I'm just going to put that right there. This one, the sum and difference pattern, know this. You will need this. Now, it doesn't mean you can't rediscover it if you forget it. Do the FOIL, you will see the outsides and the insides cancel each other out. A squared minus b squared. Okay, so those are our special products. So, to do this practice, I'll do these with you and I'll have you, I guess, do the try when we're done here. So this one is a square, right? It's a binomial square. Square the first, square the last. I just find it easier doing it that way. 9 times y times 2. That's 18y. Square the first. What? What's 9 times y?
9
Times 2.
18. Oh, I get it now.
And again, if you're not seeing the pattern, multiply this out. Expand out. There's your y squared. You have a 9y plus a 9y. There's your 18y. 9 times 9 is 81. Okay, negative 4 times x is negative 4x times 2. Negative 8x. That's if you're using the pattern. If not, do the expansion. There's your x squared. Minus 4x minus 4x. That's your minus 8x. Minus 4 times minus 4 is 16. So if you don't have this pattern, don't worry about it. Expand them out. Always expand them out. Okay. So I'm using the pattern. So square the first. square the last. 7x times 2 is 14x, right?
Yeah.
Times 2.
Oh, I got that.
Did you get that?
Yeah.
Good. And if you don't see it, just expand out. 49x squared, there's 14x plus 14x, that's 28x plus 2. Using the pattern, that's 36x squared plus a 25y squared. What's in the middle? 6x times negative 5y is negative 30xy times 2. Negative 60xy. What? If your head's about to explode, just go ahead and expand them out. Don't forget to expand them out. 6x times 6x, that's 36x squared. 6x times negative 5y, negative 30xy. Same thing again, negative 30xy, they add together negative 60xy. Multiply the lasts. What do you think? This one's a little bit trickier. If the pattern is too much, just expand and use FOIL. This one, however, the sum and difference pattern is a little bit easier. Excuse me, if you notice, these are the same except for plus minus. So m squared minus 80 what? How'd I get there? And 9 times negative 9. Because what happens to the outsides and the insides? Negative 9m plus 9m cancel each other out. What's this one? I'm noticing the pattern. X minus 4, x plus 4. The minus comes first. So what? X squared minus 16. This pattern's much easier. What's this, guys? The same thing except for a minus and a plus. 7f times 7f.
49x.
Squared. F times f, right? Minus 1. 1 times 1. You're multiplying. What about this guy?
Squared minus
6.
Multiply, multiply, multiply. You are multiplying. Okay? Now you're going to try it yourself. Okay? You're going to try it yourself. If this pattern, which is a little harder, is too hard, expand them out first and use FOIL. Give these a try. But I've got the answers up if you want to check your work. Now these, I would say these ones are a little bit harder. A through E. I'm hoping F, G, H, I go faster. I think this pattern is easier to work with than this one. If the pattern is hard, just expand it for the top 5. That's fine. What? Part of it? We haven't got to the good stuff yet.
No. Oh boy, look at that.
It's the easy stuff. It's the
Oh.
easy part.
No, I
Oh,
quit.
yes. So how do we do? Maybe it took a little work the first 5, correct? Were we able to fly through F, G, H, and I?
Yeah.
This is a really sum and difference pattern. Don't forget it. We're going to be seeing that pattern again. We'll be seeing the other one too, but especially this one. Questions on the special products. You can always expand them out and just use FOIL.
Wait, so how do you do that in one?
What?
It's the same answer.
You can do FOIL. I don't mind you if you FOIL out these, that's fine. This one I really want you to know. I want you to know this pattern. It's easy enough to see, right? Negative AB, positive AB, outsides, insides, cancel out. Okay. We're ready for the good stuff now. We're going to do some division. Suppose what? The area of a garden, area of a rectangular garden is 45 square feet. Area of a so area is 45 square feet, right? And the length is 9 feet. What's the width?
5.
Yeah, 45 divided by 2, because let's say it's x, so 9 times x is 45, right? So we divide both sides by 9. So this would be 5, right? That's how you do it with numbers. So now suppose that it's a different thing. The area is 5x squared minus 17x minus 22. And if you're looking for this on your paper, I don't think it's on.
Yeah,
So we're just looking at this. So now this is your area is 5x squared. One of them, the length is x minus 4. What's the width? So isn't the same thing divide? So I have to be able to say, well, here's the area. If I divide by the length, I'm going to get the width. So learning how to do this is the trick. Okay? So this is one of the reasons why we have to learn how to divide. You also need to learn how to divide. You're going to need an algebra too when you start graphing, special graphing stuff. So we need to know how to do this. So dividing polynomials, it really is a lot of the same steps as when we did numbers. So we're going to divide this using long division, but I really want you to think about the process. You probably do this in autopilot now, just boom, boom, boom. Let's think about what you do. So you say 3. 3 times some number gives me 6. What's that number?
2.
And how do you get there? You said 6 divided by 3. Then what's the next step? You multiply this, right? 2 times 3 goes underneath. You subtract, right? Isn't this how we do long division?
Yeah.
Okay, so the 0 comes down, and then we say we'll bring down to 9, and we repeat the process. We say 3 times something gives me 9. And the way you find that out is you say what's 9 divided by 3? Multiply. 3 times 3 is 9. Subtract. Bring down the other number. 3 goes into 3. Ooh. 1 time. 1 times 3 is 3. What's my remainder? 0. Right? Right? Okay. What if I want to do 4 into 7 to 9? I'm going to do the same steps. So 4 into 7. Yeah, it doesn't go, but there's only one 4 in 7, right? So you do 1 times 4 is 4. Subtract, now we have a 3. Bring down. 4 into 32. 4 times what? 8. 8 times 4 is 32. That's not there isn't a remainder, but I still have a 9 to bring down here. Now 4, how many 4s in 9, right?
2.
There are 2 of them. 2 times 4, right? Multiply. Subtract, 1 left over. Now sometimes you might have said R1 or 0.1. What about the fraction? Remember how to have this as a fraction? No? They never taught you this. It's over this.
Oh yeah, they did. Never mind.
They did, didn't they?
Yeah,
Oh, I'm going to have to call all the elementary school teachers. Right?
My elementary school teacher.
She did, right?
Like, yeah.
Who'd you have?
I wasn't here for elementary school.
Oh, you went somewhere else. That's why you have it.
I didn't have it.
I didn't
I
have it.
didn't.
Well, you have it now.
And I was
What you
like,
do, shush, is the remainder over what you're dividing by, your divisor. 182 and 1/4. That's the same thing. If you want to bring down the decimals, believe me, you get a 0.25 there. Don't forget to verify. So how do I know I did this right? You multiply back. You multiply back, you get that number. So that's how you do it with numbers. So when you're using polynomials, we're using variables now, it's really the same steps. So here I'm dividing x cubed plus 4x squared plus 5x divided by x. So x times something is x cubed. How do I find what that something is? Well, divide it. What's x cubed divided by x?
X squared.
X cubed over x is what?
X squared.
Isn't it? Remember how that works? You got
Oh,
three
yeah, you
factors
subtract.
out, one factor cross out,
Oh, yeah.
or subtract those exponents. Then what? Multiply. That's what we did with numbers. What's x squared times x?
X squared.
X cubed.
Oh, perfect.
Yeah. Then we subtract. X cubed minus x cubed is 0. We're going to bring down that 4x squared. I'm putting the plus in because that's a 0 and that's an x squared. Same thing. X times something gives me 4x squared. And you can find that something by just dividing. What's 4x squared over x? No? 4x. 4x.
3x.
Now we multiply. What's 4x times an x?
4x squared.
4x squared. Subtract. Then we're going to bring down that one. X times what gives you 5x? 5. 5 times x is 5x. 0 remainder, right?
Wasn't it 4x times squared? Or is it not?
4x times x gives me 4x squared. Yeah? Now for ones like this, you can think of this like this as well. Think of it as the fraction. How would you use this as a fraction? Don't you go this way, and this way? So what's x cubed over x? 4x squared over x. What's 5x over x? I personally think it's easier
Oh.
if you're dividing by a monomial, this is easier, for sure. But we're doing this to kind of prove a point. We're looking at process. That's the process. If for real somebody asked me to do it, I would do it this way. It's faster, right? But you could do it this way. Okay. So another way is to make it a fraction. That's what I did here. But we're using the long division mostly just to practice this process. Okay, so we're going to practice this process. So 3x into 6x cubed. Well, first of all, 3 into how many 3's in 6? 2, right? And then x times what is x cubed? X squared, right? Multiply, because that's what you do with numbers. You should get the exact same number. If you've done this right, you're going to get the same number. Bring down that 3x squared. 3x times what gives you 3x squared? How do you tell me? X. X times 3x. You should get the same number back. Subtract. Bring down that negative 12x. So 3x times what is negative 12x?
Negative 4x.
Negative 4 times 3x. Negative 12x. Now I'm subtracting a negative, right? It's a positive to get to 0. And again, this would be easier. I personally think this is easier. If somebody gave you this question on, say, an SOL exam, I would do this way. I think it's easier to see it going like this. 2x squared plus x minus what? But that's okay. You can do it this way.
Might be easier if they're all multiple.
Yes, it's easy. What?
So when you have a question like this, can you turn it into that?
I could, unless it says in the example solved by long division. Otherwise, yes. Like if it's on a test and I just want to see you know how to do it, I might say solve by long division. But if it just says divide, you could do that. Sure. Okay, 4y into 12y cubed. All right, 4 into 12, right, that's a 3. Y times what is y to the third power? 4y to the third. Multiply that. You should get the same number if you did this right. Bring this guy down. 4y times what? Is negative 16y cubed. Well, the numbers, right, that's a negative 4. And y times what is a y cubed? Y squared, right? Let's multiply back. Negative 16y cubed. It should be the same thing. You're subtracting that. You get a 0. Bring down your 20y squared. 4y times what is 20y squared? Well, do the numbers. 420, right, that's a 5. Y times what is y squared? And that gives you 20y squared. Subtract it, right? Is this so bad?
No.
This is hard? You just gotta work it backwards. Well, let's try this one then. Okay, so Ryan, do the numbers first.
I mean, like what happens if, say it's like 5, and like 3 or 5x, and then it's like,
Doesn't work so nice?
yeah, and it doesn't go.
Yeah, well, then we're in trouble. We're doing them where they're nice. We're working with nice ones now. So negative 5x into 15x cubed. Ooh, well, it's negative 5. I want a 15. I'm going to need a negative 3 here, right?
Yeah.
And then x times what is x cubed? Multiply back. You should get the same number. If you don't, you made a mistake up here. Subtract. Bring down this guy. Negative 5x times what is negative 10x squared?
2x.
2x. Because negative 5, negative 10, right? That's 2. Okay, so 2x, that's negative 10x squared. And your check is when you multiply back, they should match. Subtract that. Bring down this guy. Negative 5x times what is negative 20x?
4.
Positive 4, right? 4 times negative 5x. Okay. So when you're dividing by a monomial, it's really not that hard. And honestly, if it was me, I would turn it into this. I see it a little bit easier this way. I'm okay with it. Honestly, that's how I would do it. Now the question is, what if it's not a nice one for you? Yeah. Okay. These you try. Take a second. Just do these. Okay. So it sounds like we all were able to do at least 1 or 2 in the small amount of time I gave you. Are there questions? And some of you are asking good things like, I don't need to do all that. I see it. The only reason I'm making you go through this is I want you to learn that process. You multiply, you subtract, you bring down, you repeat, right? So when we get to dividing by a binomial, it's a little bit different. Okay, so again, so dividing. Oh, what you want to make sure the thing you're dividing by, your dividend, is in descending degree order. So it's in its standard form. Okay. You're going to be multiplying back by all terms, and the subtraction step is tricky. So rather than looking at the talking, let's just do this one. Okay, so this one, we're towards the bottom of the page now. What you do is you say, okay, x minus 1, I don't know, let's make a guess. X into x squared, what would I multiply by to get x squared? X times what? X. That's what I'm going to start with. So you put the x up here. Yeah, I still hear little buzzy noises. Everybody's quiet.
That was my chair.
Okay, now you're talking still. So when you multiply back, what are you multiplying? X times x minus 1. What's x times x minus 1?
X squared minus 1x.
X squared minus x. What? You do x times x times negative 1. And then you are subtracting. We're subtracting. Think about what that does. You're subtracting this whole thing. First of all, you've got an x squared minus an x squared. You should always have that match where it disappears. But what's happening here? It's 2x minus negative x. This is really a plus x, isn't it?
Yeah.
So when you do that subtraction, you get 3x. Yes, you do. Okay, so let's review. You said you found the number here, you multiplied, you subtracted, then you bring down. So again, the steps are the same, but it's a little trickier now. Repeat x minus 1 into this. Now you say again, you look at x and you look at 3x. X times what gives you 3x? Plus 3, because 3, right? Multiply back. What are you multiplying? 3 times x. And 3 times negative 1, which is negative 3. Subtract whole thing. See how I'm putting parentheses here? Oh. And that's 3x minus 3x. That should always be 0. Negative 3 minus minus 3. That's a plus 3, which is 0. What's the quotient? X plus 3.
Oh.
Yeah.
Well, this is equal to
Yeah, because go backwards. How do you check it? What's x minus 1 times x plus 3? Is that how you check whether you did the division right? You multiply. You get x squared plus 3x minus x the inside minus 3. What's 3x minus an x? 2x. And I get what I started with. Yes. Okay. Now you will learn another way to approach this. You can do this as well. We are going to learn how to factor in our next unit, which will help you do it this way if you don't want to use long division. Sometimes, though, you have to divide using long division. You have to learn how to do this. Yes, ma'am?
I'm so confused on what you did with the minus 1.
Oh, you're multiplying back, right? Don't you take this and multiply by what you're dividing by? So x times x and x times minus 1.
Yeah, but I'm saying like to get the answer. And how
Well, to figure out what to multiply up here, I don't worry about the minus 1. Let's do another example, okay? Let's do another one. These are some more examples on your paper here. So watch what's going on here. So you make sure these are in descending degree order. You also have to have all terms here. If one was missing, you put a 0 in. Let's not worry about that yet. You say x to x squared. How do you get there? You multiply by x. When you multiply back, again, I hear a lot of things that aren't listening sounds. They are fooling around sounds. Look up and watch. You're multiplying x times this full divisor. So that's a distribution. What's x times x? What's x times negative 1? Okay. Group this because I'm going to subtract the whole thing. Remember how subtraction worked where you distributed the negative? You can think of it as the same way. That becomes negative, this one's going to become positive. These should always disappear. A 2x plus an x is a 3x. You will bring down the minus 2. Who is with me so far? I don't know if I'm answering your question, Brenna, about the 1, the minus 1. It's part of the things you're multiplying by. Repeat. Yes?
Okay, so we're doing x squared plus 2x minus
I am doing this question right here. It's near the bottom of the page too.
Yeah.
I don't know what.
X, like at the top.
X squared plus 2x minus 2. Divided by x minus 1. Yeah? And we figured out x is first. Now I'm working on this one. X, how do we get to 3x? Times, right, so plus 3. When you multiply back, you get 3x. 3 times a negative 1. Who's with me so far? Subtract. 3x minus 3x. That should always cancel. What's happening here? Minus 2 minus a minus. That's a plus 3. I've got a 1. I have a remainder. Right? How does that work? How did it work with numbers?
1 over x.
Right. Plus, see this plus? Important. Plus what? 1 over x minus 1.
I know it.
That's how you handle a remainder. Yes. No.
We're doing that.
Let's try this one. 2x. How did I get to 2x squared? Multiply by what?
Multiply by x squared.
X. Now let's multiply back. What's x times 2x?
Where did you get that?
We're going to get what?
Oh,
X
no,
times
no.
negative 3. Okay, I just multiply x by here. So try, see how I'm putting parentheses? Make sure you're doing the same thing. Minus that whole thing. 2x squared minus 2x. That should always cancel out if you did this right. 11x minus minus
14.
x times negative 3.
Oh,
Times x. Bring down the minus 9. Repeat. 2x times what is 14x?
7.
I'm kidding.
7.
Oh, 7.
7 times 2x. 7 times negative 3. Subtract. This is going to become a plus 21, isn't it? These cancel out. But negative 9 plus 21. Is it 12?
Yeah.
That's my remainder. Plus 12 over
2x minus 3.
This thing. Okay. Let's try one more. 3x to 9x squared. What do you multiply to there? 3 and an x. Multiply this whole thing by 3x. 3x times 3x is 9x squared. 3x times negative 4, negative 12x. Subtract. Well, that makes this become plus, doesn't it? Minus 1. 18x. Bring down that plus 8. Repeat. 3x times what gets me to 18x? 6. Multiply. 6 times 3x. 6 times negative 4. Multiply, right? 6 times 4, right? And then I subtract. Oh, that becomes a plus 24. I'm subtracting 32. My remainder plus 32 over 3x minus 4. Whoa! What? Because now it's your turn. Yes, it is. Give them a try. Okay, so you're working on these. This is what I got. Do we at least get the first one?
Yeah. The first one. Still doing it. Wait.
I'm going to do the first one. So you have x minus 2. Look at this. Okay, x to 3x squared. What do you multiply to get there? 3x. Multiply 3x times x. 3x times negative 2. You're subtracting, so that's really a plus 6x. So add negative x, that's a 5x. minus 10, right, bring that down, x to 5x, how'd I get there? 5 times x, 5 times negative 2, subtract, it's a 0 remainder. Which part? What? How did I get the first 5? I said here's a 5x, here's an x. X times what is 5x? Or what's 5x divided by x? 5. You may need to watch this video several times. Do that. Do that. Don't just give up if you don't get it right away. This is practice. And let's say, I think that's all we need to say here.